Hi, a very warm welcome to one and all watching this video. The topic that we are going to discuss today is prediction of the frequent buyers after an online sales promotion campaign. So the team members in this particular project are myself, Saiganesh, Naveen, Arun, Kavin and Shanmugavel. So let's get into the business problem. It is quite normal for the merchants to run very big promotions in order to attract new buyers. Unfortunately, a lot of these new buyers are just one deal hunters. So these promotion campaigns have very minimal impact on the overall sales of the organization. In order to alleviate this problem, it is very important for the merchants to identify these potential one-time buyers who can be converted into regular buyers. So let's get into the introduction. So predicting the new buyers who can be converted into regular or frequent buyers is by itself a very big milestone in the online B2C industry. And in today's world, it has been identified that just about 2 to 3% of the new buyers can be converted into repeated buyers. And our project basically aims at improving the rate of predictability and therefore help the merchants to identify the potential new buyers who can be converted into repeat buyers. Our project also enables us to improve the overall profits as well as the return on investments during the particular market campaign. So let us take a look at our data source. So the data source was obtained from tmall.com, who had this particular data in order to improve the customer relationship. Let's get into the purpose. So we aim at improving the rate of predictability so as to enable the merchants in identifying the potential regular buyers. And another important goal of this project was we applied the business intelligence tools and techniques, a lot of machine learning as well as some data mining techniques in order to improve our rate of predictability.
Thank you, Saiganesh. I'm Shanmugavel Gnanasekar from Business Analytics, and I have played a major role in data preparation, and I'm here to discuss about it. In the data preparation flow, in our project included 6 steps. First is data access, understanding, consolidation, cleaning, transformation, and reduction. The main objective in our data preparation was to clean the data and prepare it, transform it, and send it to modeling and exploratory data analysis. The first stage in our data preparation was data access. We downloaded the data from Tmall website that contained customer buying patterns for 6 months period, and the data was very huge. In fact, it was 1.5 GB, and we had problems loading it in Excel or R or SAS. It was very tough that in data understanding phase we had a meeting and decided upon using technology like Python to read data as per the need into the memory. The using Python proved helpful in in creating summary statistics and calculating summary mean and mode, median, and number of records. And it is at this stage we were able to find a number of records. It was 7 million and 11 columns. After data understanding phase, we had data consolidation phase. In this phase, we merged multiple Excel files into a single file. And from both these data consolidation, data understanding phase, we were able to prepare data dictionary. This is a data dictionary we prepared, and it contains 3 columns. First one means listing the data fields, the second one the data types, and third one the data definition. The data fields gives you the variable name, like example, this user ID, it denotes unique ID for each customer. Its data type is given here as ID and definition is here. I would like to point out another variable which is very important, will become important in next slide, that is activity log. And as you can see, this activity log is combination of multiple variables like item ID, branch, number of purchases, the last purchase date, etc. The next stage is data cleaning stage. In this stage, we clean the data and brought some structure into it. For example, take the variable activity log. It was combination of multiple variables like last purchase date, number of transactions, and it had many entries for as many purchases as made by customer. So we used Python code once again to extract the values and put it in different columns. And also we decided upon using recency and frequency model. That is, we use a number of transactions made by customer and and stored it in variable called recency. And similarly we 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 found out the last purchase date of the customer and stored it in recency variable. This is a graph of the recency variable which shows the distribution of it. As you can see, the date before promotion, that is 9 November, has large number of frequency count, while the date that is way before promotion has just very low frequency count. The next phase of the our data preparation is data transformation. In this step, we uh, we transformed not non-normalized data. For example, the number of purchases in our dataset was right skewed. So we used many techniques like max normal transformation technique to find out the best normalization and transformation that would help make our variable more normal. So we using max normal technique, we found log transform works best for our data, and we transform this kind of data set into a normal distribution. The last phase of our data preparation is data reduction. In this phase, we selected the data and we eliminated records such as erroneous data, data entry errors, and other data collection issues. And this data reduction step had another step called variable selection. The problem with our data set was it had too many unrelated variables. Example is, for example, like we had add to cart frequency variable. It will be explained later, but it is irrelevant and we removed it from our data set. Other than this, we have brand ID which had about 10,000 levels, and we decided that including it in the model will make our model hard to converge, and we removed it from our model. The next slide, exploratory analysis, will be discussed by Naveen Kumaresan. Thanks.
Thank you, Shanmugavel. I am Naveen. I am here to discuss about the exploratory analysis part of modeling. Well, before moving on to the modeling stage, we did descriptive analysis on our independent variables as well as the target variable to describe and summarize the data in a meaningful way and find useful patterns in them. So the first analysis variable is age. So the age variable had values distributed between 15 and 80. So to make the processing easier, we binned the age variables across 8 levels as it is shown here. There is one level called 0. Those are people who are not willing to disclose their age. So there are around 21,000 people like that, and the remaining people falls within the remaining 8 levels as it is binned here. So if we move on to the distribution of age variable, so it is pretty normal as it is shown here, so which is a really good sign. So the next analysis variable is gender. So it has 2 levels, 0 is female and 1 is male. So if you see here, 74% of the products purchased in tmall.com are made by female. So this is a really valid point for a gender-based marketing. So the next analysis variable is a target variable. So if you see here, it has 2 levels. One is level 0, which is one-time buyers, and level 1, those are repeat buyers. If you see the difference between the number of one-time buyers and repeat buyers, which is really huge. So this is actually a rare target event, and it would cause oversampling issues. This issue is well considered, and it has been really addressed in the model creation phase. Okay, and then we move on to the next variable. So the next variable is click frequency. It is nothing but click to view product frequency. Like if a customer clicks a product to view what it is. So the distribution shows there are a lot of outliers, and also it is right skewed. Because of this, there is a huge variation between the mean of the variable, the mode, and the median of the variable. So, and this issue is also being addressed in the later stage. So the next variable is add to cart frequency. So add to cart frequency has 3 levels. So first level is 0. It is nothing but if a customer goes on to the website, if he adds a product to the cart and if he made a purchase, then it will fall under level 0. If he add one product and he didn't make a purchase, then it will fall under level 1. So if he had 2 products and he didn't make a purchase, then it will fall under level 2. So if you see here, 19 more like almost 100% of data is belongs to level 0. That is, whoever have added product to the cart, they have made a purchase. That's a really interesting factor. So and then we move on to the next variable, which is purchase frequency. So this is nothing but the number of products purchased by the customers. If you see here, if you take the three levels like 1, 2 and 3, it covers like 95% of the purchases made. There is also one link between the purchase frequency and the add to cart frequency. If the purchase frequency is higher, then the add to cart, the level 0 in the add to cart frequency will be high. So if you see here, the purchase frequency is really high. So if you move on to the previous variable, I mean the add to cart frequency. So almost 99% of people have fall under level 0. So it is a really interesting factor. So the next stage is exploratory analysis, will be discussed by Arun. Thank you.
Thank you, Naveen. I am Arun and I am going to discuss about the exploratory data analysis. First, let's start with what is an exploratory analysis and why it is being used in the data analysis, and finally let's see some of the observations we found in our data set. Exploratory analysis is an approach to analyze the data sets to summarize their main characteristics with visual methods. Primarily, exploratory analysis is for seeing what the data can tell us beyond the formal modeling. It encourages to explore the data and possibly formulate hypotheses that could lead to new data collection techniques and experiments. Although it looks like the descriptive statistics that was described earlier, exploratory analysis focuses more on checking the assumptions required for model fitting and hypothesis testing, and handling missing values and making transformations of variables as needed. Now let's take a look at this graph, which shows the target variable versus the gender variable. It is obvious that the percentage of female customers are more for one-time buyers and repeat buyers. This can be used to make some managerial decisions. In this case, merchants can target more on the female customers rather than the male customers. Next, we have the target variable, which is the age group variable. Here the repeat customers are higher in the age groups 3 and 4, which corresponds to the age groups 25 to 29 and 30 to 34. Here the null group indicates that the values of ages are unknown, or the customers have not disclosed their age. Next, we have the buyer count, which is the click frequency variable. It is seen that the data is skewed towards the right. This is possibly because of the fact there are many potential outliers in the click frequency variable. These outliers need to be removed before building the model. We have considered a cutoff value of 5 standard deviations to remove the outliers. Here, since the data is right skewed, we have used the match normal transformation technique to find the best technique to normalize the data, and we found that log transformation was the best technique in order to normalize the distribution of this variable. The normalization of the variable is required to satisfy the assumptions of regression. Moving on to the next, we have the target variable, which is the purchase frequency, which is plotted in the box and whisker plots. It is obvious that the purchase frequency variables have many outliers for both the one-time buyers and repeat buyers. This is due to the fact that there is a large variability in this variable, and hence we need to remove these outliers before building the model in order to decrease their error variance and improve the prediction accuracy. Again, this is done by a max normal transformation technique, and we found that log transformation was the best technique to remove the outliers. Next, we have the QQ plot to check the normality of the data. Here the click frequency variable is plotted against the target variables, and it is obvious that the data distribution is not normal in this case. Hence, we need to normalize this data by removing the potential outliers and transformation of the data. We have used the log transformation technique to normalize this data and also to satisfy the assumptions of regression. Moving on to the next, we have the correlation analysis done between the continuous variables click frequency, purchase frequency, and add to cart, add to favorite frequency with the target variable. And we found that these continuous variables have a significant linear relationship with the target variable. This is determined by the p-values which are lesser than 0.001 for all the continuous variables. This indicates that there is a significant chance that these variables will be included in the final model. The next model building section will be explained in detail by Kavin. Thank you.
Thank you, Arun. I am Kavin. I'll walk you through the model building and model selection techniques. The first question is, why should we need a model? Well, if you pose a question to the data should be able to provide the answer, and that is possible with the help of a model. We studied the input variables and we found that they fall under these two categories, namely the categorical and continuous. The modeling techniques that we used were logistic regression, decision tree, and neural networks. We decided on these techniques based on the input variables and the exploratory analysis that we did. We did the model in SAS Enterprise Miner, and this is the project window screen. I'll walk you through the different nodes that we used. The first node is the project data itself. This is the master data with outliers and without any data cleaning that was performed on the data. We did the descriptive statistics using this node, DMDB, and found that there were many outliers. Hence, we had to filter the data. That was done with the help of filter node. And the descriptive statistics were studied again, and we confirmed that the outliers had been removed. The next process in this is to sample the data with the help of sample node. We basically undersampled the data to match the target levels. Then we had to partition the data that was performed using the data partition node. We basically partitioned the data into 3 blocks. The first was training data set, the second was the validation data set, and third was the test data set with 60, 30, 10 percentages. Then we found that there are many missing values, hence we had to use the impute node. Then we had to transform the variables because we found that there were 3 variables which were basically right skewed, and we had to normalize them in order to have a good prediction of the output. We fed these data into the 3 modeling techniques, the ones which I explained already, namely the decision tree, neural network, and the regression. And then these 3 models were combined into a single model using the ensemble node. So at the end of this particular point, we had 4 different models, and we did a comparison on those and found that neural network was predicting, neural network basically represented the model the best way than others. Let me walk you through the different nodes that we used in an elaborate way. The first is data filtering. We found, as explained already, there were many outliers in the data. We had to remove those outliers because if we didn't do that, then the error variance would increase and the prediction accuracy would decrease. Hence, we had to filter the data, and we did this based on the 5 standard deviations from the mean. So those data which were above 5 standard deviations were removed. The next was data sampling. When you look at this particular picture, you can see the different target levels. One is 0 and the other is 1. So 0 is a one-time buyer, and the frequency of that particular variable is around 91,000, and the predicting buyer is 1, which had a frequency of around 7,000. So since there was a lot of unbalance and variation present in these 2 target levels, we had to undersample the data. If we didn't undersample the data, then that would probably create a lot of bias in the model. So we had to undersample the data using the sample node. Then we had to partition the data, as I explained. 60%, 30%, and 10% were the cutoff percentages that were used to split the data. Basically, the training data set was used to build the statistical models. Validation data set was used to select the best model out of all the 3. And the test data is used to find the prediction error. And then we did the data imputation. We found that these 2 observations, basically the age range and gender, had a lot of missing values. We had to use tree imputation technique for the categorical variables and mean imputation for the continuous variables. Then comes the variable transformation. As I told you already, all the 3 variables, namely the add to favorite, click frequency, and purchase frequency, were right skewed, and we had to normalize them. Hence, we had to use max normal transformation technique, and this technique is basically will predict which transformation technique it should use. And this provided us with the log transformation technique as the best technique to normalize the data. And then we had to, so the different fit statistics were studied. The first is for the logistic regression. The fit statistic for logistic regression showed that the prediction accuracy is 56%. For the neural network, the prediction accuracy was 57.96%, and for the decision tree, it was 57.51%. So out of these three techniques, the neural network performed better because the misclassification rate is the lowest. And then we also studied the ensemble model and found that out of these 4 models, the neural network performed better than the other 3. And then comes the model assessment. So misclassification rate was the basis. So on basis of the misclassification rate, we did the study and found that neural network performed better than the other 3 techniques. So the misclassification rate for neural network was 42.04. The lessons learned and the conclusions would be delivered by Saiganesh. Thank you.
Thanks a lot, Kavin, for your valuable inputs. So let us take a look at some of our key findings. Among them, the first one would be, so we've determined that the female customers have higher odds of becoming our repeated customers. So it is essential for the merchants to target the female customers during a marketing campaign. And then the next one would be, we've also determined that the ages 25 to 29 and 30 to 34 have the higher chances of becoming repeated customers. And the last one would be that if the number of clicks made in order to view a product is between the range of 16 to 18, it can be seen that there's a 90% probability that that particular customer will be a repeated buyer. Okay, so some of the lessons, important lessons that we've learned at the end of the project would be, the first one is time management. So from the very beginning, we did micromanage our schedule in such a way that we could meet our deadline. And this helped us throughout our project so that we could meet our deadlines. So the next one is our teamwork. So it's always essential for everyone to pull together in order to achieve a lot of things. So we did make sure that everyone chips in order to complete our tasks. And then the last one being the modeling techniques. So in order to achieve better results, we need to build better models. So it's always essential to concentrate on the models and make sure that we build the right model at the right time. Thank you.